Okay, good afternoon to one and all present. Let us begin the session with a moment of silent prayer. Respected resource person, faculty, participants, and research scholars, a warm welcome to day 2 of our faculty development program. We had an enriching first day, which set a strong foundation for our academic journey. Dr. Ramesh Babu introduced us to the basics of AMO software and structural equation modeling, providing valuable conceptual clarity. So today we continue that journey with fresh insights and deeper learning. We are delighted to have the same distinguished resource person with us for the next segment as well. Without further delay, I now hand over the platform back to our esteemed resource person to lead us into the next session. Over to you, sir. Thank you.
Thank you, Anisha ma'am. So today we will continue as where we left yesterday. So let me share the document here. So I hope this is where we left yesterday, like types of SEM. So today we are gonna do only path analysis. Tomorrow for confirmatory factor analysis. So before we actually conduct the path analysis or demonstrate how to do the path analysis, so I'd like to take you through few content about what do you mean by path analysis and what is the context that you use path analysis. All right. So after that, I will be using data which is publicly available online data, where I'll share the uh, references as well from which study I have taken this data in order to demonstrate the path analysis. So now let us understand the basic introduction about the path analysis. So the path analysis was developed by Sowell Wright. He is a geneticist working at the US Department of Agriculture. If you look at the initial applications of path analysis, basically involved in quantifying the contribution of genes versus environment and assessing whether the temperature, humidity, and radiation or wind velocity which had any effect on the transpiration in plants. This is what the initial application. But for several decades, the path analysis was not able to get into that kind of a fame what the application what we are using path analysis on a regular basis. It almost took some few decades to actually get this kind of a fame. So the now, if you look at the path analysis, I think in behavioral sciences, even in management and other fields, we are using extensively. So let us now see what do you mean by path analysis. So path analysis starts when you actually construct a path diagram containing the predictor and the outcome variables, which is independent and your dependent variables, and all of which are supposed to be measured variables. There are no a kind of other variables which are latent variables. So for example, a path analysis does not contain any latent variables. If at all you are placing a latent variable in your path structure, which transforms the analysis to a structural equation modeling. So you need to remember this or understand this. The moment we say we are using path analysis, so we are using all measured variables. So here the measured variables then connected to other measured variables using the directional arrows. Yesterday in class we learned that there is a unidirectional and bidirectional arrows, because these directional arrows basically represents the hypothesized flows or the relationships or the influence or causal linkages. So for example, yesterday also we learned another instance. We learned that multiple regression or sum is basically a series of multiple linear regressions, right? That is what we have seen yesterday. So here, whether you use the multiple regression or a model fitting, which is structural equation modeling analysis, then you compute to determine what is the values of these path coefficients or the regression coefficients. So these path coefficients are nothing but the regression coefficients, whether you call it as a standardized coefficient or unstandardized coefficients. These are gleaned from the appropriate analysis, whether you have used the model fitting or multiple linear regressions. So here, when the results of the path analysis are presented in a graphical or a pictorial form, it is the standardized regression, which is beta coefficients, that are typically provided in the diagram. So I will explain you, but once we analyze it, you also get the unstandardized regression coefficients, but we only show the standardized regression coefficients or the beta coefficients. So basically, the path analysis is a variation of the approach taken in multiple linear regression. Because you see that, remember that I said that it is a series of multiple linear regressions, what we do in the structural equation modeling. In the multiple linear regression approach, we actually designate a set of variables as predictors, and in order to find the influence on outcome variable. So where in the multiple linear regression, you have one outcome variable, and which was measured in a continuous data using continuous variable, and you have several predictor variables, which can be probably continuous variable or categorical variables. So that's where we use the multiple linear regression. But in the multiple linear regressions, what we do is we place them all the variables into the prediction model, and with their weights within that set of variables optimized in the data analysis to minimize any prediction error, and we tend to determine how well each of the predictor variable predict your outcome variable. So this is what we do in the multiple linear regression. So for example, let us look into this picture which um, I came here. So you can see here a schematic drawing of a standard multiple linear regression analysis in the form of a path diagram. So you have here variable A, variable B, variable C, and these variables are currently operating together or in a parallel manner in order to predict the variable D. So this you can consider as the simplest possible structure we can construct to predict the variable D. So when you are doing this, you can call this as a multiple linear regression, or because there are three types of multiple linear regressions, as you are all aware of: standard or simultaneous multiple linear regression, hierarchical or sequential multiple linear regression, and other stepwise regression. But we here, when you are dealing all the variables parallelly, simultaneously, we call it as a standardized multiple linear regression. So this particular pictorial graph shows that all those variables, variable A to C, are simultaneously working in order to predict the variable D. So here the variable A, B, and C sometimes maybe often are related to each other in a more complex way than simply as a members of the predictive type. So that's the difference between the path analysis and the multiple linear regression. Because the regression structure, which I have shown just illustrated earlier, does not capture the possibility of any interrelationship among the predictor variables, which I shown that predictor, variable A, B, C. So in the multiple linear regressions, that you cannot see that whether is there any possibility that these variables have interrelationships. For this particular reason only, we as a researchers are increasingly being drawn to path analysis as an alternative to the multiple linear regression, because that's the limitation, because it cannot see any possible interrelationship among the predictor variables while predicting the dependent variable. So for that reason, we use this path analysis. So one of the strongest appeals of the path analysis over multiple linear regression is that the researchers can formulate a path model or a path diagram to articulate their understanding of the interrelationship among those variables that would serve in multiple linear regression simply as a set of predictors. So when I mentioned that all variable A, B, C or simultaneously or parallelly trying to predict D, so where you cannot articulate any interrelationship in the multiple linear regression, but path analysis, of course, you can do. That's thus the use of the term path model as an it's very descriptive of what the researchers are trying to do, because the moment I see a pictorial graph in the path analysis, as a reader, right, I can able to understand that what the author is trying to portray or trying to do here, because I can see the kind of arrows that are drawn, the which variable is trying to predict from which variable. All right. So here the model or the path diagram that you develop basically represents your hypothesis of how the variables are related to each other. In this particular path diagram, often you can also designate the strengths. So for example, what is the relative strength of the relationship, whether you are predicting or you are assuming there is a strong strength or a moderate or a weak, or what kind of a relationship, whether you are looking for any direct relationship or an indirect relationship that you expect to be signified by this path coefficient in your model. So here, after performing the path analysis, you are then able to evaluate how well your model is performed, and if it is appropriate, you may wish to respecify your model in some way, meaning you can add or remove a particular path or another variable. Then you can see that which model is better fitting to your theoretical assumptions. So for example, when you add a particular variable, if you think that the model is not fitting well, so you can remove that particular variable. Then you can also add another variable and see that which model is more appropriate. So now, by having said, or given this particular understanding of the path analysis, let us try to learn how to do the path analysis using data, like available data or the internet. So here I'm using this particular paper. I request all of you to go through the paper, because the data which I'm currently using uh, comes from this Ingram paper, Ingram et al. So basically, which was published in 2000 in the Journal of Social and Behavior and Personality. The title of the paper is Applying to Graduate School, a test of the theory of the planned behavior. So this is the paper which I'm using. After trying yourself, after I demonstrate, you can also try doing yourself during our class time, next 1.5 hour before 6 o'clock. You see that whether you are finding it any difficulty while practicing it, I'll be here to help you, because after demonstrating, we'll be looking at the model fit indices, whether the model is fit and what are the parameters that we'll be looking into it. So in this particular paper, if you it is available in the Ibasco, this one, because other in Google and all, you will not be able to get it. If you have an access to Ibasco, probably you will be able to get this particular paper. So in this paper, there are 5 variables the authors have used it. Like the context for this paper is, like they are using this theory of planned behavior in order to predict the behavior to apply for graduate programs, and also what is the intentions to apply this graduate program, like what is the actual behavior. So if you look at this path analysis, the picture, it shows that there are three independent variable: attitude towards the graduate applications or the programs, are the subjective norms, and the perceived behavioral control. Then you also have the other dependent variable, intent, and the other dependent variable, which is the behavior. So if you read the paper, I recommend all of you to just go through the paper once you complete this course today, like tonight. Probably that you will get the maximum, like understanding by just doing this. So here, if you look at the picture, so why these people prefer the path analysis over the multiple linear regression? Because if you wanted to see this particular, study, you can also do two multiple linear regressions. How do you do the two multiple linear regressions here? Because you see, we have 3 independent variables or predictor variables and 2 outcome variables. If you see this arrows marking, the behavior is directly influenced by the intention, the intent variable from the PBC, like, which is perceived behavioral control. Uh, because there are two, there is an arrow from PBC to directly to the behavior, and there is a direct arrow from the intent to behavior. Similarly, there is also another multiple linear regression, because here you have two independent predictor variables and one dependent variable. Simultaneously, the intention as an outcome variable, you can also check from the, or predict, you are also will be able to predict which of the variable, predictor variable is the better predictor for the intention, which is attitude, subjective norms, and the PBC. So this is what, all these three variables, there is an arrow towards the intention. But we are trying to learn the path analysis, because in this multiple linear regression analysis, as I mentioned earlier, you cannot be able to see any possible interrelationship among the predictor variables that are shown here in the bidirectional arrows. You can see a bidirectional arrow here, between perceived behavioral control between PBC and attitude, and also PBC and subjective norm, and also subjective norm towards the attitude. And altogether, like, how, whether this model better fit or not. So this is what we are going to learn using this path analysis. So now let us, I hope you have received the data which I shared with the Anisha ma'am. So in order to work with the data, you should have had the Amos, working Amos. And also in order to open the data, probably you should have had the SPSS, because any other platform that the file may not be opening, all right? So uh, let me take you through the data. I'm stop sharing my PowerPoint presentation. Now I'm sharing my screen. So, and I'll show that how to how to run this particular analysis. So let me share my full screen for, yeah, path analysis. So just confirm me whether it is visible to all of you, the
Yes,
file.
sir, it's visible, sir.
Yeah. So now you look at this particular data set. You have 5 variables here. You have attitude, subjective norm, perceived behavioral control that you can see in the label, and the intent, intention, and you also have behavior. So remember, all multiple linear, whether regression or path analysis, is primarily based on the correlation, which means that we expect there is a correlation among the variables. Then only it works, either regression or path analysis. Let us try to understand whether these variables we have got any correlations existing. So in order to run this, I think I need to enlarge a little bit. So here you can see that go to analyze in order to run the correlation. I think most of you know that, but still I'm using this correlation and select the bivariate, and usually all these variables in your left side. Then you move to the variable section, and here you have the options: Pearson's correlation, Kendall-Stauby, and the Spearman. So if you want to find out in non-parametric correlation, which is Spearman, you can even click the Spearman. But I assume that the data is normally distributed. I'm only selecting the option for Pearson's correlation. Then go to the option. Then, any missing values, make sure that you use the exclude cases pairwise. If any missing values, the data will exclude, SPSS will exclude any cases pairwise. And if you want, you can also select the means and standard deviation if you wanted to know the mean of those variables and the standard deviation. For us, it is not required at present, so I have only checked this, exclude cases pairwise, and continue. Then when you click, your output is shown here. So now you can clearly see that our variables are correlated with each other. You can see this attitude is positively correlated with subjective norm and also positively correlated with perceived behavioral control and also positively correlated with intention and the behavior. You can also see subjective norm is also positively correlated with perceived behavioral control, intention and behavior, and whereas perceived behavioral control is also positively correlated with intention as well as the behavior. So by just looking at it, we can say that yes, of course, we have the enough correlations in order to run this. So what we do is now we just simply run multiple linear regression, then we compare with the path analysis. Because here you can go to analyze, because as I mentioned here, go to regression button, analyze regression, and click on the linear regression. So here in the first model, if you look at the graph where I said that intention as a predictor variable, because there are three arrows that are directly going towards the intention, which is
Sir, we
attitude.
can't see the graph, sir.
You not the graph. Can you see this one? I'm just explaining now.
Okay, spaces.
Yeah, this linear regression you could see, right?
No, sir.
No, this.
Only the data attitude, subnorm PBC.
Yeah, that you can see, right? Other than this
Yes.
correlation
Data
table.
view. Data view
Yeah,
we can see.
data view you can see, right?
Yes, sir.
So I have shown the picture, no, ma'am, earlier that I said
Yes.
that there are two multiple linear regressions that can be drawn. So in
Yes,
this
sir.
case, we are just trying to test the multiple linear regression, whether which variable is the better predicting the intention here. So for example, in order to do that, I've selected intention as my dependent variable and attitude, subjective norm and perceived behavioral control as the predictor variable. Then make sure that your method is enter, not stepwise or backward. We are not, because we are using simultaneous or standard multiple linear regression. Then you need to click on the statistics and make sure that you click on these under the regression coefficients, estimates, confidence intervals at the level of 95%, and you can click on the model fit. And because we wanted to see the descriptive statistics, you can click on the descriptive statistics, part and partial correlations. You can also check the any collinearity diagnosis, and under the residual you can click on the case wise diagnosis. So what does it mean is it actually takes plus or minus 3 standard deviation. Any outliers if are there in your data, it actually exclude that. So case wise diagnosis, I'm clicking on outliers outside 3 standard deviations. Then
Sir, those
you
things we can't see, sir. You're telling I'm clicking on.
you are not able to see, ma'am, that whole
Yes. Yes, yes. The
okay.
process which you are doing, we are not able to see.
Oh, sorry. I think Aishi also raised hand. What is Aishi? Is the same thing what ma'am has said. Let me share my whole screen, ma'am.
Okay, sir.
Yeah, I think otherwise share. Which option is screen? I think I'm sharing the screen, right?
Yes, sir. Yes, sir. Now we can see correlation, sir.
Can you
Correlation.
see that? So now what
Yeah,
I'm
yes, yes.
okay, sorry. Then I thought you are able to see. Let me check
Okay,
few
sir.
messages are there. Check the messages now. If there any other thing, I'll address. Otherwise,
Same
I
thing only,
can't.
sir. We can't see the results.
Okay,
That's
okay,
what this.
okay, fine. So now, in order to run the multiple linear regression, I'm selecting this regression from analyze section. Under the regression, you have these options. Click on the linear regression. First, as I mentioned, there are two multiple linear regressions can be done looking at the figure. So the first one is I'm trying to predict the intention because intention is my outcome variable. And whereas I had three independent variables, because in the figure also it shows that attitude, subjective norms and PBCs are directly shown, towards the intention, that arrow. So that's the reason I have clicked I've selected these three independent variables. Then I'm making sure that under the method, I'm selecting the enter. I'm not selecting stepwise remove backward or forward approach, because I'm running the standard or a simultaneous multiple linear regression. So make sure that this option is entered as enter, method enter. Then you can click on the statistics button under the regression coefficients, right? When you are running the multiple linear regression, you can select the estimates and confidence interval 95%, and make sure that you select also model fit, descriptive statistics, part and partial correlation, and the collinearity degree, diagnostics. For certain, I think uh, I'm currently using the SPSS 31 version. When I'm click the multiple linear regression, these are all by default entered, especially estimate, model fit, and whichever other things which I wanted, I can select it by clicking on that particular this model fit or R squared change. So then under the residual, I'm clicking on, you can also click on the case-wise diagnostics. Under this, I'm clicking the outliers outside 3 standard deviations, which means that if you have any outliers which falling under plus or minus 3 standard deviations, the SPSS make sure that it diagnoses at their backend, and it will not be selected for the data, like for us to run this. So once you select this residuals, click continue, then go to the options button, and by default these options will be given. Make sure that under the missing values, make sure that you click on the exclude cases pairwise. If there are any missing values for any of your data, so it makes sure that it excludes the cases pairwise. Then click continue after that. Then you can click on the plots button. So under the plots button, you click on this ZPRED. It goes to the your X variable, which is your independent variable, and ZRESID, it should go to the move to the Y variable. So then under the standardized residual plots, if you want to see the data, you can also click on the histogram, but it's not necessary. If you wanted to see how it looks like, you can click on the normal probability plot. The once you click on, then click this OK button. So once you click on, immediately that analysis will show this, that output will show that. So what we did is, I hope you can see the output regression.
Yes, sir.
Yeah.
Okay.
You see that we have used these variables, descriptive statistics, you can see intention, attitude, subjective norm, and perceived behavioral control, their mean score and standard deviation. You can also see the correlations among these variables. But what is that we are more interested in it, this ANOVA table, because we wanted to see that whether as a model, all these variables are statistically significantly predicting your outcome variable. That you can check here by looking at the significance value, because here the significance value is less than 0.05 level. You can say that the model is significant. All right. After looking at this model significant, you can go down and check this coefficient table, and which variable is the better predictor for the predicting this intention behavior. So you can see that there is unstandardized coefficient as well as the standardized coefficients. So we are looking at the standardized coefficients. Standardized coefficients are nothing but correlation coefficients or the regression coefficients. So you can see that attitude is the better predictor, because it is significant, is less than 0.05 level, and also the standardized regression coefficient is 0.807, right, is a better predictor. The followed by the perceived behavioral control, and this one is not the statistically significant, because these significance values falls above 0.05 level of significance. All right. So we have seen that now by looking at the regression. When we are parallelly when all the variables are simultaneously trying to predict our outcome variable intention, we found that that attitudes is the better predictor for the predicting your intentions to apply for a graduate program. Now, similarly, the other multiple linear regression that we can use it, because you can see here in this picture, we have done as of now this intention, right? Now we try to predict the behavior from the two independent variable, which is your intention, because there is an arrow from intention to direct arrow from intention to behavior, and there is a direct arrow from your pursued behavioral control to behavior, right? So this model we will test now using the multiple linear regression. For that, again, you can go to the regression and the same old procedure. Otherwise, shortcut, you can click on this particular option. When you click on whatever we recently have performed, it will be shown here. So the click here, the regression, the make sure that all these variables are sent back, and even the dependent variable move to the your left side, because here our outcome variable is the behavior as for the picture. Now what I'm trying to predict is, the first one is whether intention is the better predictor or not, intention, and also this perceived behavioral control, and all other options are the same. You need not to do it anything if you are doing at the same time, because all options by this time would have been already given. Excuse me. So we need not to do it once again. You just, because since it is already given, you just click OK. Now you can see the second multiple linear regression model which you have done. Now here, as I mentioned here, this is to just to cross check whether you have correlations or what is the means and standard deviations. But as I mentioned, we are more interested in whether the model is significant or not. So here you can see that by looking at the significance value on our table, we can see that the model is predicting. So now once you know that your the overall two variables are predicting, will be statistically significantly predicting your outcome variable, you can see that which variable is the better predictor. You see that here uh, intention is the better predictor here. You see that the standardizer coefficient or the correlation coefficient or a regression coefficient is 0.35. 35% is a variation is comes from this. So you can see that the value is also exactly is equivalent to 0.05, right? Uh, then you can say that the intention, these are the two variables, like from the previous model, attitude, and this multiple linear regression, intention is a better predictor. Now, so why we are not doing multiple linear regression? Why are we doing the path analysis? Is that the same reason? Because we need not to do two different or multiple linear regressions, right? We can do a simple path analysis for all the variables, and you can see that I know what is the model fit. And also at the same time, we are also path analysis is able to perform, is there any other interrelationship among your predictor variables, that as I have shown here, right? So as you can see here, it is trying to see this bidirectional arrows. So is there any interrelationship, how that is able to predict it? Now I'll be closing this output because output is not required as of now. So now you can perform using this path analysis. So you can click on the icon which you had this path Amos. I'm currently using Amos 31 edition. Uh, so here, as I explained yesterday, you need to draw, because we are using path analysis. We are looking for only the measured variables, not the latent variables. In this case, I need to select this draw observed variables. So there are different ways you can do it. Either you can just draw a diagram and click on this draw observed variables, right? Or draw unobserved variables, like anything you can do it. Or else Also, you can simply click on this icon, right? So you can see this icon is here. So I can simply make sure that, click on your mouse and drag like this, all right? Whichever size you wanted, all right? So I'm just dragging here. So I have 5 measured variables here. Either I can drag 5 times, all right? Or else in a simple manner, what I can do is just go back and unclick, then click on this duplicate objects. So after unclicking this particular icon, I can click this one. So what I can do is now I can duplicate, all right? I can just draw how many ever I want, like, so I'm doing it. I'm just trying to draw 5 different, this one, all right? So once I've done this, unclick, click once again, so it will be unclicked. So now once you are done, as per the model, I need to draw the paths first. So in this case, I need to click on this, like, single headed arrow, because I wanted to show that which are the paths that I'm using. So I'm using, so before that, let us try to, identify the variable. Otherwise, right, you will get confused. So here I can click here, go to object properties, right? Then I can mention what is this variable. So I can click attitude. I can enter this variable as attitude. Then when I click it, it came. Then I can click here. No need to go back and right click once again. So here, as I mentioned, I'll be mentioning as the subjective norms. Subjective norms. Then I can click here. Then it will give the other, select another variable. Here I'm using the pursued behavioral control, and click here and type, you can type here is intention, all right? And finally you click here, you need to type, this is the other outcome variable, you say behavior, all right? So then close the object properties. Then, because based on the theoretical model which I shown in my PPT earlier, so we can draw. I've selected this single headed arrow in order to show the path. I'm selecting, when you go to the variable, it will come as like, a red color, right? So you click here, then you can take to this. When it shows as a green color, which means that it is drawn that, the path, your pursued behavioral control to behavior. And also there is a single headed arrow in our model that we are trying to predict whether intention predicts the behavior. And you can also see that the subjective norms to intentions and your attitudes towards the intention, all right? So when you have done this, we have to draw this other bidirectional, other other bidirectional arrows. So because I wanted to see that whether is there any interrelationships. What I can see here is, I can see the interrelationship between perceived behavioral control and subjective norms, and the subjective norms to attitude. And I can also, I wanted to see as well this perceived behavioral control to attitude, all right? So this is the model. But now here I also need to see, is there any measurement error or error, all right, on my, other than these 3 variables, is there anything that I can see? For that, you need to select this error icon, all right? Add a unique variable to an existing variable. So you click here and you click here. So when you click here, it will be added unique error variance, right? So here, once you added the unique error variance, and you can go to the object properties, you can mention here as error variance. You can mention ERR1 error variance and click on this because the another error variance ERR2. Then
Dear participants, there is a technical glitch from SAR's part. So SAR will be joining within 5 minutes. Kindly please wait. Yes, sir. Yes, sir. Now audible.
yeah, sorry to everyone. Actually, there was a power glitch here, and I have a MacBook, but usually Amos doesn't support Mac. Only it supports Windows. That's the reason I'm using my computer. So there is no option for me uh, other than waiting. So let us. I think I these models I have not saved while I'm teaching. Uh, I think I need to start again to draw. So is it visible to all of you?
Yes, sir. Yes, sir. It's
Yeah.
visible.
So I'm quickly drawing, right? Since I have explained how to draw, you can also check here while I'm drawing. So select here, and I'm selecting three measured variables, and I'm selecting the duplicate. Yeah, and then click here. Then here I want to draw paths here using the single-headed arrows. And now I need to draw the bidirectional arrows, like interrelationship among my predictor variables. So after this, I have drawn this unique error variance for the outcome variable. Then now let us label these variables because we have not labeled it. The first variable, just right click, go to object properties, type attitude, attitude. This is intention, subjective norms. You can click here and pursuit behavioral control. And this is behavior, right? Then you close it. Now you had, sorry, I think I need to add this error as well. Error 1 to my first dependent variable, and error 2 this, my second dependent variable. So now I completed drawing the model. Now I select the data. So here I can go. Here you see the list of variables in the data set, or here list variables, or I can also go to file, interface, analysis properties, sorry, not analysis.
Sir? Participants, Sir is having some power issue in his end, so we can continue in the next day. Tomorrow, sharp at 4:30, we will be starting. So kindly join on time. Thank you so much. All can fill the feedback form also. Thank you so much. And sorry for the trouble. Thank you. Sir, you can end the meeting.